In this session, we will talk about nested classes. A nested class is a class in Java that is supported where it exists within the block of code of another class. So this is an outer class here. This is its opening braces. Within it, there is another class, a class definition or declaration, nested class, and then end of the outer class. So a class within another class is allowed in Java. That is what we call a nested class. It's a member of the outer class. So let me go and demonstrate that. This is an outer class. If I needed to have a nested class by the same name, I'll just call it that so we can use this as notes. Yeah? Nested class. So an outer class and a nested class. This nested class is within the outer class. Next, we have two types of nested classes. There's the inner class and the static nested one. So the non-static or the static one. So let me just go back here to demonstrate that. There are two types of nested classes. We have the inner class and we have the nested static class. So the static class. Static class. Let me just call it static class. Simpler. Okay. In a previous session, we had spoken about class methods or static methods. There are some rules about the class methods that apply for the static class. So, for example, it cannot access instance variables or methods directly, even though it can access static variables and static methods directly. The same does not apply for instance variables, and we'll see an example of that. So the same way a static method would need to work via the object reference to access instance variables, then also in a static class, same rules applies. So just to clarify, it cannot, although the inner class can access this instance variable directly, the static class cannot access the instance variable directly. We want to test this out, that if there is an instance variable, the inner class can access it directly, while the outer class, the static class cannot. So here we go. If there is an instance variable, instance variable, let's initialize it to 0 just because the inner class can access the instance variable directly. So if I have a method here, void method inner class, and I access instance variable, I can do so directly. If I had a method inside this, void inside the static class, then I cannot access the instance variable directly. In fact, it has no way of identifying that there is any other variable like that. So we had seen this in static methods earlier. Yeah, so take note of that. We had seen this in static methods earlier. So this would, I expect the nested class to work the same way as the inner class, because I just used it earlier to show us what a nested class is, but that's that. Okay. That is one, it cannot access the static, it cannot access the instance variable directly, okay? But it can access the static variables directly. So static int class variable, we call it class variable or static variable. If you learned this in a previous session. So let's see, can it access the class variable directly? Yes, it can. In fact, it recognizes it. Let's reset that to 6. There you go. Okay. So what will happen if it must access the instance variable? If it must access the instance variable, then it can only do so via an object reference. So ref is equals to new outer class, then work with the outer ref to access the instance variable and set it to 9. For example, if there was a variable in the inner class, an instance variable, instance var inner, to access it from the static class, I'll need to work with 2 object references. So the object reference for the outer class and the object reference of the inner class, like that. So only then can I access the instance variable in the inner class. There you go. So that is how it works. This is treated as a top-level class, and if you're accessing members of an inner class, you will need to go via 2 object references, the one for the outer class and the one for the inner class. This one is just 1 object reference if you're going for this instance variable. So let's see if this will work. If I have a static int for instance class variable in inner, how can I access it? If I come in here and type class variable inner, I cannot see it. It's within the inner class, so I'll still need to go via the inner ref. So inner ref, actually I can just use the name inner class because it's a static reference and access the class variable like you would as we learned in the previous session. So I can go via the object. Like I said in the previous session, it's possible to go via the object reference to access the class, the static variable, but it's discouraged. So this, I can either do this via the object reference, or just, if I want to be sure for the code readers that this is a static variable, I just go via the class name as we did before. So what I expect us to see is that the static class is treated as a top-level class when it comes to the rules of accessing other class members. And like the inner class, because it's it can have access to the instances of the outer class. Okay, yeah, so this has been demonstrated. It works almost the same way as a static method, if not exactly the same. So it can, from the inner class, you can access the instance variable directly. From the static class, you need to go via an object reference. So we have top-level access modifiers, public and package private. This one will apply on the outer class. However, inner classes or nested classes are treated as members of a class. So the private and the protected access modifiers are also supported. So public, private, protected, and package private, which was covered in the previous session, can be applied on an inner class. Just to clarify on that, this is a top-level class. It can be public or package private. Package private meaning it doesn't have a modifier. It, however, cannot be private. There's an error, compile time error. It cannot be protected. Compile time error. But because the nested classes are treated as class members, I can make it protected or I can make it private. Same applies to the static one. I can make this private. That is why one of the reasons for working with inner classes is encapsulation. we had talked about encapsulation in the previous session. So I can make it private, I can make it protected. It's a member, it's treated as a member level. So member level access applies to it. Public, private, protected, and package private. I believe this has been covered. The private, protected, all are supported. The reasons why: encapsulation, because you can make it private to improve readability and to group them all together. If, for example, all these classes needed to work together, then we have all of them there. So it's easy to logically group them and to improve the readability of our code. So other classes we have, local class and anonymous class. We'll talk about them in the next sessions. These are the classes that exist within a method body. They are inner classes, yes, but they exist within a method body, or rather a block of code between parentheses, which it's usually a method. So we'll see about them. Now, I had included this screenshot from the official documentation, whose link is in the description, because I wanted to let you all know that with some of the latest JDKs, some of the rules for Java 8 have changed. So if you work with the official documentation, the rules that are listed there are for Java 8. However, as of Java 16, some of the rules changed. For example, an inner class is associated with an instance of its enclosing class and has direct access to them. And it says that it cannot define any static members itself. Up to Java 15 or JDK 15. Up to JDK 15, this was true. But from JDK 16 moving forward, this is no longer true. An inner class can define static members. And I have demonstrated that this is an inner class and it has a static member. So let me just add a comment here in case you never know. This is an static member. So as of JDK 16 moving forward, I'm currently demonstrating with JDK 22. So if you're working with the official documentation, make a point of checking. Some of the rules might no longer apply with the latest JDKs, just so you know. And sometimes I might remember to mention it. Sometimes it might totally skip my head. Or maybe in future, if you're seeing this from the future, because I'm on JDK 22, if you're seeing this on higher numbers, some of the rules might have changed. Just take note of it. Okay, so as I've already demonstrated, this static inner class is treated, or static nested class is treated as a top level class. So if I wanted to access it, and like when I wanted to access the inner class, I accessed it via the outer class reference. If I wanted to access the static class, I can just access it like any other top level class. So I can go ahead and create static class object and use it as it is, which is not possible on this other side. So let me just show us how it's not possible in a class, in a ref is equals to new in a class. See, it is not possible for me to create an inner class object reference and access it directly outside of the outer class. But it is possible for me to just create a static class object reference. It is treated like any other class, any other top level class, that is. Yeah, so for the inner class, you have to go by the outer class. Okay. All right, and now to the shadow test. So given that we had talked about shadowing, shadowing is when you have variables with the same name as the parameters in a method or the same name as other variables within class members. So given that the inner classes are members of an outer class, how is shadowing handled for them? This shadow test class helps us unpack that. There is a link to the shadow test class in the description. Have a look at that. I'll also make a point of attaching an additional link to an outer class so you can practice on your own. Here we go. This is the shadow test class. It has a variable int x. It's our outer class. This is our inner class, first level. It has a variable by the same name, but it has initialized it to 1. Then it has a method inside it, and this method prints x from the parameter, from the arguments that will be passed in. Then it prints this x, and the first this refers to the instance of the first level class. This one refers to the instance of the first level class, and this one refers to the instance of the outer class. So if you want to refer to the instance of an outer class, you will need to call the name of the outer class, then call this, and then refer to that variable. So let's see how this will work. I'll make a point of showing you that we had learned in the very first sessions that these string arguments can either be square, brackets, or dot, 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 among other supported options. So you're getting to see that here. Now, on the first line of our main method, which is the entry to our code, we have shadow test object creation, our outer class object creation. Let me just say outer class here. Outer class. Then next we have the inner class object creation. Like I have demonstrated, you have to go via the outer class. So shadow test first level class, the name, and the instantiation of the same. So through that, we want to invoke method in first level. So with our method invocation, we are passing the value of x as 23. Let's go to that method that has been invoked. So we expect this to print 23. We expect this to print 1 because it is making a reference to the instance of first level. And we expect this to print 0 because it's making a reference to the instance of shadow test. So let's run this and see. 23 is what I expect to see. Yeah, there we go. 23, 1, 0. So play around with that. Make sure you understand what's going on so you can know how to handle shadowing for nested classes. This has been a little bit longer than you're used to in the previous sessions, but I'll see you on the next one where we'll discuss local classes, then anonymous classes, then lambda, and so on and so forth.